Hello everyone. Today let us study one more theorem called Pythagoras Theorem, which is a very famous theorem of mathematics. What does Pythagoras say? Pythagoras say that in a right angle triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. Now what is hypotenuse? Suppose I draw this is a right angle triangle. One angle is 90. The sum of the other two angles should be 90. And which is the hypotenuse? The side opposite to 90, and that is the longest side. Because you know the side opposite to the larger angle is larger than the side opposite to the smaller angle. So if this is ABC and AC square is equal to AB square plus BC square, that's what Pythagoras says. So that is what we want to prove in a theorem. So shall we start? Yes. Come on. So I draw this triangle in some other way. I draw like this. See, this is 90 degree. This is B. This is A. This is C. So which is hypotenuse? AC is the hypotenuse. So what is given? I have to write down. ABC is a right angled triangle which is right angled at B. ABC is a right angled triangle which is right angled at B. What is to prove? To prove the side opposite to right angle is called AC square. AC square is equal to AB square plus BC square. You look at this theorem. In a right angle triangle, so I drew the right angle triangle. What is the next one? The square on the hypotenuse, AC square is equal to AB square plus BC square. That is what I have to prove. Now, before proving that, let me do one construction. I draw BD perpendicular to AC. What I do? I draw construction, draw BD perpendicular to AC. Did you all understand it here? Now when I draw BD perpendicular to AC, I get three triangles. What are those? This is one original triangle, this is one triangle, this is the other triangle. For my reference, for my easiness, what I do is, I draw these three triangles in a pencil lightly. For my reference, okay. Now, first one is the original one, right angled at B. Next one, all the both right angled at D. I hope you understood. How to name, that is very important. One is right angled at B, other two are right angled at D. First one is right angled at B, the other two is right angled at D. Now which is the first one? I take B, A as the base. So first one is original one. A, B, C is the vertex. Another one, D, see this is A, so this is also A. Okay. D, A, and this is one B. Another one, I want C on the top. So C and D. What is my idea? Suppose I take ABC and ADB. I take A is common. See, this is A is the common. If I take ABC and BDC, I get C as the common. So that is my idea to draw the right angle triangle and name it. So now onwards I need not refer this. Directly I can refer that and it will be very easy for my proof. So construction is over. Now let me start the proof. Very important and very easy. What I do is, first one, I refer the original one with the first one. Which is the original one? In right angle triangle ABC and right angle triangle ADB. What is the first one? Angle ABC is equal to angle ADB is equal to 90. What is the reason? Given and construction. Another one, angle BAC is equal to angle BAC is equal to angle DAB. Is it correct? BAC is equal to DAB. Yes, correct. Why? Common. Therefore, angle, which is the remaining? This angle is over, this angle is over, AA, common is angle over. This is the remaining. Angle BCA is equal to angle DBA by remaining angle. Therefore, right-angled triangle ABC is similar because AAA similarity criteria. So, I can say ABC is similar to triangle ADB. Right? Once I say, because they are equiangular, AAA. So, I can say now corresponding sides BC by BD. Therefore, BC by BD is equal to AB by AD is equal to AC by AB. Now, my question is, I have to get either AB square or BC square. From this, what I may be able to get? Here you see AB repeats twice. So, I can take these two. AB by AD is equal to AC by AB. And I do the cross multiplication. What do I get? AB square is equal to AC into AD. So, what did I get? AB square, I read on here and I want to rub the board. That is why AC into AD. I said, when I draw BD perpendicular AC, divides the triangle into two parts, and hence I got three triangles. One is the original ABC, another one ADB, another one BDC. And according to my convenience, I gave the name. One is right angled at B, other two right angled at D. Another one, A is common, you see. A, B, A, C and B, A, D. That is why I wrote A and A. Automatically other one will be C will be common. So, it is very easy for me to, prove that they are similar. So, I proved these are similar and I got AB square is equal to AC into AD. Now, what is my next aim? My next aim is to take, what do I take? ABC, the original triangle with this triangle. Shall we try? I take the original triangle. What is that? In right angle triangle, which is that? ABC and triangle BDC. First point, angle ABC is equal to angle BDC is equal to 90 degree. Why? Given and construction. Second one, angle BCA is equal to angle DCB. Why? Common angle. Therefore, angle BAC is equal to angle DBC. Why? Remaining angle. Therefore, right angle triangle ABC is similar to right angle triangle BDC. Therefore, by AAA similarity criteria. Therefore, now we say BC by CD is equal to AB by BD is equal to AC by BC. AC by BC. Now I have to get, here I got AB square, maybe I have to get BC square, right? See, if you take the first one and third one, I get BC by CD is equal to AC by BC. BC square is equal to AC into CD. I call it as 2. That one 1 and that one 2. Now what I have to do is, I have to add those two. What is that? When you add, what will I get? Let us see. When I add, I get AB square plus BC square is equal to AC into AD plus AC into CD. See, I am adding this. If 1 and 2, AB square plus BC square is equal to AC into AD plus AC into CD. So, you get AC common, AD plus CD. What is AD plus CD? AC is equal to AC into AC is equal to AC square. Therefore, AB square plus BC square is equal to AC square. That's the theorem. This is called Pythagoras Theorem. So, you have to know this properly because it is a very important theorem. What does Pythagoras say? In a right angle triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. So, explain this. So, ABC is a right angle at B, construction BD perpendicular to AC. That is why I get 3 triangles, original triangle, this triangle and this triangle. I told you how to make common and name it. Then it is very easy from this only to write down all this. I hope you understood. Now let me solve 1 or 2 problems. Before I solve the problem, what is the converse of Pythagoras theorem? The Pythagoras theorem converse says, if in a triangle, the square on the longest side is equal to the sum of the squares of the other two sides, then those two sides contain a right angle. What is the meaning of that? The theorem says like this, converse. If in a triangle, suppose I say it is in a triangle, the square on the longest side is equal to the sum of the squares of the other two sides. This, if it is AC and this is B, if AC square is equal to AB square plus BC square, then those two sides contain a right angle. That is called converse. Understand? So, Pythagoras theorem says in a right angle triangle, the square on the hypotenuse is equal to sum of the squares of the other two sides. Converse of the theorem says, if in a triangle, the square on the longest side is equal to the sum of the squares of the other two sides, then those two sides contain a right angle. I hope you understand. That is called converse. Now let me solve 1 or 2 problems on the Pythagoras theorem in this class. First question is, the first question is like this. In the figure, CD is perpendicular to AB. What type of triangle it is? Right angle triangle ACB, right angle at C. CD is perpendicular to AB. Prove that BC square by AC square is equal to BD by AD. When BC square, AC square all comes, what can I do is, you know, if at all it is right 90 degree, AC square plus BC square is equal to AB square. Nothing is given like that. They have given BC square by AC square. Maybe they have taken these 3 triangles as I had taken just now. So, let me draw 3 triangles. One original triangle, second triangle, third triangle. Okay? Original triangle is right angle at C, base is A, B. Now, let me draw another 2, D, right angle at D. So, D, A, you get common. So DAC. Another one D. So D, you have to get here B. D, B, so C. So now you can prove that they are equiangular and similar. See, just now as I proved, you can prove this is similar to this is similar to this. Now I am not going to prove. See, listen how to prove. Suppose this question comes for 3 marks, first you have to prove that they are similar. I will tell you how to prove. This is 90, this is common, so this is remaining. In this and this one, this is 90, this is common, and these are remaining, right? So now my aim is to get BC square. So where BC comes, here BC comes, here BC comes. So how do I start? See, here BC comes, here BC comes. So I take these two triangles and say that it is similar. Think that it has come for 1 or 2 marks. I need not prove that similar, but I know how to prove that similar. Did you understand? I told you the method. This is 90, this is common, this is the remaining. In this and this one, this is 90, this is common and this is the remaining, right? Now, I want BC square. BC and BC comes here. So I write down right angle triangle ABC is similar to right angle triangle BBC. If you study like this, the whole Pythagoras theorem will be very easy. And this type of problems you can solve very easily. Right angle triangle ABC is similar to right angle triangle BDC. Therefore, corresponding side you say BC by BD, see BC by BD is equal to AC by DC is equal to AB by BC. Or wherever BC comes, that only I can take. I need not write on this also. So BC by BD is equal to AB by BC. Cross multiplication. BC square is equal to AB into BD. Now look at that. AC square I have to get. Where AC comes? AC is here, AC is here. So I take these two triangles. Right angle triangle ABC is similar to right angle triangle ADC. That's what I write down first. So I want AC. Wherever AC comes, that side I will take. AC by AD is equal to AB by AC, AB by AC. I do the cross multiplication. AC square is equal to AB into AD. So now I do the next. Therefore, BC square by AC square is equal to what is BC square? BD. What is BC square I got? AB BD divided by AC square AB AD. AB get cancels is equal to BD by AD. Is our answer correct? And we proved within no time. If you understand like this, it is very easy to solve all the types of problems. Now let us go to the second problem. A ladder is placed against a wall. How the ladder should be and how the wall is straight. The ladder should be like this. A ladder is placed against a wall and its foot is at a distance of 2.5 meter from the wall. See, this is the foot of the wall, this is the foot of the ladder. So this is 2.5 meter from the wall, right? And its top reaches the window sill and its top. This is the ladder. Ladder's top reaches the window sill 6 meter above the ground. So what is the length of the ladder? Understand? So what is the length of the ladder? Let me call it as A, B, C. Right? AC is a ladder. AB is a wall and BC is the distance between the foot of the ladder to the foot of the wall, right? So AC square, this is 90, ball is straight always. So AC square is equal to, let me write down, in a right-angled triangle ABC, right, angle B is equal to 90 degree. Therefore, AC square is equal to AB square plus BC square. So AC square is equal to 6 square plus 2.5 the whole square. 36 plus 25 is a 625. 6.25 is equal to 42.25. I taught you already how to find out the square root if it ends with 25. I said 15 square you have to divide it into two parts. 5 5s are 25. 1 2s are 225. Suppose if it is 65, 5 5s are 25. 6 7s are 42. 6 into next number. See, you get the same number 42.25. So what is that the square? 6.5. So the length of the ladder is 6.5. Did you all understand? Now let us solve the last problem and let me conclude this class. Now look at the third example. The question is like this. They have drawn the figure AD perpendicular to BC. Right? Prove that AB square plus CD square is equal to BD square plus AC square. All looks very complicated. It is very simple. What you have to do is, whenever this is 90 degree, you write down using this 90 degree Pythagoras Theorem, this 90 degree Pythagoras Theorem. When I use right-angled triangle ABD, in triangle ABD, angle ADB is equal to 90. Am I right? Therefore, what will happen? If this is 90, AB square is equal to AD square plus BD square. Now, another right angle triangle. This is not 90. They have not given it is 90. So, only these two 90. So, in triangle, right angle triangle, which one? ADC, angle ADC is equal to 90. Therefore, using this is 90. So, AC square is equal to AD square plus DC square. You have understood this? So, in triangle ADC, angle ADC is equal to 90. AC square is equal to AD square plus DC square. Now, look at the last one. What is given? AB square plus CD square. Where is AB square? Is here. Where is CD square? Is here. So, in order to get CD this side, I think I have to AB square minus AC square if I do. DC square will come this side, subtract, then it comes this side. I think like that I have to do, isn't it? So, AB square minus AC square is equal to AD square plus BD square minus AD square plus DC square. So take out the bracket. AD square plus BD square minus CD square minus DC square. So what do I get? Here AB square minus AC square. I have to get AB square plus CD square is equal to AD square minus CD square get cancels, BD square plus AC square, and this is our result. I think you have understood the theorem as well as these three problems. If you like my video, please share it with others and subscribe. Thank you everyone.